when we are subtracting polynomials, it's a little different than addition. So in addition, you have to think about what is outside of parentheses. Anytime you see parentheses and you have completed all tasks on the inside of the parentheses, you have to look to the outside and say, okay, what's happening? What's attached? And what do I need to do to make sure it gets inside of those parentheses? So in addition, on the outside of the parentheses of the second polynomial, there was a positive 1. Well, positive 1 doesn't change anything. Yet when we come to subtraction, it's no longer a positive 1. There's actually a negative 1 out here, and that does change something. So if you think about anything on the outside of parentheses means I need to take that and distribute it through or multiply it to every one inside. So what we need to do for subtraction is to make sure that we are taking that negative 1 to everybody inside. So I'm going to rewrite this problem. So I'm going to keep the first polynomial doesn't change. There's nothing on the outside of the front of our first polynomial, so I'm just going to rewrite it. P squared plus p plus 3. And then I'm going to distribute the negative 1. What's negative 1 times negative 4? Well, that's positive 4. So plus 4p squared. Negative 1 times negative p. Well, that's just plus 1p. And then negative times positive 3, so now I have negative 3. Now this looks just like addition. Everything's back to the way it was before. We're just combining like terms. So p squared, p squared plus 4p squared. That would be 5p squared. And then I have a p and a p, so plus 2p. And then I have my constants. I have a 3 and a negative, wait a second, 3 minus 3. What's 3 minus 3? That's 0. So I just don't write anything. So your answer to combining these through subtraction would be 5p squared plus 2p. I want to briefly look at that very carefully here, though, if you are looking at doing it vertically. If you noticed, before in addition, we didn't keep the parentheses when we lined them up vertically. I have to keep those parentheses until I distribute that 1. Until the 1 out here has gone through, I need those parentheses. So I could rewrite this, or I could distribute it and say, well, I want this to be positive, so I want this guy to be the opposite of a negative, which is a positive. This one is the opposite of a negative, which is a positive. The 3 was already positive, so I'm going to add my negative here. Now I can add vertically. And I have 4p squared and 5p, or 2p, let me try that again. 4p squared and p squared, when I add those, that makes 5p squared. That's a tongue twister. P and p, when I add those, I get 2p. And 3 minus 3 is still 0. So the answer is the same. The caution is you have to be very careful when you're distributing that negative 1 out front. It has to go all the way through that second polynomial, or you're going to get mixed up. Okay, I want to look here briefly. Again, we have 2 polynomials. We actually have 2 binomials with subtraction in between. So remember, that's like a negative 1 inside here that needs to be distributed. That's important to remember. And then you just follow your regular order. So negative k plus 5 stays the same. Then I now have negative 3k squared because I distributed the negative 1, and negative 1 times negative 6 gives me positive 6. Then I combine like terms. So we just go straight into standard form. So negative 3k squared minus k plus 11. Where we want to be careful with is if you tried to line this up using vertical. So if I just started writing this vertically, I would have negative k plus 5 subtract, well, that's 3k squared. That means it's going to have to go out front. That doesn't align with negative k. Nothing aligns with negative k. And then I got the negative 6 over here. So if you go to line them up vertically, you have to be very careful. And then after I line them up, I still have to distribute that negative and make that a positive 1 by changing that 3 to a negative and that 6 to a positive. So I still end up with negative 3k squared minus k plus 11. But vertically in subtraction, you have to be very, very careful about where everything is placed and how that negative goes all the way through the bottom polynomial or the second polynomial in order to make sure you have those lined up correctly.